Okay, I think these will be the last set of videos for this unit. This is lesson 2.7, Solutions, Stoichiometry, and Titrations. And when you think about stoichiometry, I wrote Stoich, what that really means is quantitative analysis. So analysis is to figure out what you have, and quantitative means numbers, not just descriptions. So you're trying to figure out, by analyzing your reactions, how much of something that you'll have. Titrations will be one way that we'll do this. So I have here some text, and I've put some of these bullets in your notes. I want to touch on them for a second before we talk about stoichiometry. At this point, this unit is a unit on solutions, and specifically reactions that happen in solution. So a reaction that happens primarily in water or something else. Has to be a liquid, has to be a solution, a mixture of something with another liquid. You've learned different types of reactions that can happen in solutions. You've learned you can have a precipitate reaction. You've learned you can have an acid and base react and produce water and a salt and possibly something else. You've learned you can have reduction and oxidation take place. We call that redox. That means electrons are being transferred from one substance to another. Those are the three types of reactions we've learned. Now you're at a point where you can start to analyze, if you're given reactants that are aqueous, what type of products will they produce? And once you figure that out, what do you think is going to happen? This is the reason in first year chemistry you learn things called double replacement and single replacement, and we sort of overgeneralize to teach those types of reactions. The reason we learn types is so that you can start to, if you see a certain type of reaction, think of what the products might be. So you're learning how to predict products based upon the types of reactants that you have. That's what the first thing you want to think about when you're analyzing a chemical reaction to predict products is, what are the reactants? Sometimes it's hard to predict products. Products can really only be determined by this way, this word, experiment. But many people, before you were born, did many experiments, so we know a lot about chemistry now. So you've learned some rules based on their experiments, and you can use those to try to predict products, and then see if what you in the lab make really fits with that, or if it makes sense. So you have a couple of bullets on your paper. The first thing, if I give you on a test or a quiz 2 products, or even in your homework packet, you want to look at the reactants and say, what are they? If you have 2 ionic solids, let's make some of this smaller. That didn't work out how I hoped. If I squeeze it smaller, you can't read anything. If you have 2 ionic salts, then those are both going to be electrolytes. They might combine to make a precipitate. That would be you learned that as a double replacement reaction. If you have reactants but one of them is a non-electrolyte, that means it's not ionic, so you're probably not, it's not going to act as a double replacement, because in order to have a double replacement and create a precipitate, you really need to have 2 ionic salts, because the ions have to switch. No electrons switch in this type of reaction, only ions. So electrolytes would make a precipitate, but if you have a non-electrolyte, probably not going to happen. Are they acids and bases? Well, if you have one acid and one base, then you're going to have then they're going to neutralize each other and probably give you a water and a salt. This is what I was talking about before. If the reactants are electrolytes, metathesis is another way of saying double replacement. It's what this text comes from the Brown-LeMay book, which I like a little bit better than the Zumdahl, but they're both good. Will they make a precipitate? Will water come out? Will a gas come out? You have to look at what happens when those electrolytes move around, when those ions rearrange. If the ions cannot rearrange, that's what, if metathesis cannot occur, That means if the ions cannot rearrange, you can't have a double replacement, that's what this means, then can an oxidation reduction happen? Because if you're having double replacement, you are not having single replacement. Single replacement is going to be redox. Can't have both. So if you can't have double replacement, well, can you have a redox reaction? That means that you have to have electrons being transferred, and it means you have to have both reduction and oxidation. So that's when we assign our little imaginary oxidation numbers and see if they change in the reaction. So it's very important to be able to predict what happens. You're going to be asked to do that. Now, if you take time to read this text, if you pause the video, you'll see here, your prediction might not always be entirely correct. Now, hopefully on the test it will be. I'll make it pretty easy. But in science, and when we're doing labs, and in real life in science, your prediction may not be entirely correct, but it might lead you down the right path. So that's, as a chemist, you want to start to go down a path, and then in the lab you will figure things out. And so I think, as Forrest Gump says, that's all I have to say about that. Moving on. So once we predict products and write a balanced reaction, balanced, no, you can't read that. That's when we can use stoichiometry or quantitative analysis to figure out how much of something we might need or might make. That's what this question is asking. How many grams of calcium hydroxide are needed to neutralize 25 milliliters of 0.1 molar nitric acid, HNO3? You need to memorize this. It's a strong acid. It's on your list of acids to memorize. So they give us two reactants here. They ask us how many grams of this we need. In order to figure that out, we're going to need a balanced reaction. So in order to write a balanced reaction, we need to know what these two things are going to do when they react. So we're going to look at them. There's a clue here. It says neutralization. You don't always have that. But calcium hydroxide has a hydroxide ion. It's a base. This you've memorized as one of your strong acids. An acid and a base are going to combine, neutralize each other, and make water and a salt. So let's write that down. I suggest you pause, try to write it, and then check your work. So hopefully you paused the video and came up with this equation. This is balanced. The calcium hydroxide and the nitric acid combine. Your proton here is donated to your hydroxide group to make water. Your positive ion combines with your negative ion here to make calcium nitrate, an ionic salt. You need two nitrates because every calcium ion forms an ion that has a +2 charge. It's in group 2. And then I balanced it. So now we have a balanced reaction. Now the question is, how many grams are needed to neutralize 25 milliliters of 0.1 molar HNO3? So I write down what I'm looking for. Question mark, grams. I'm putting it under the calcium hydroxide. Okay. Well, actually, should I put that there? Yeah, I think that works. And then I'm told I have this much of the nitric acid. So I have 25.0 milliliters of 0.100 molar, and I'm writing that under the nitric acid, so it applies to that. In fact, we can circle that in purple. Okay, now, in order to figure out how many grams I need of this, I'm going to need to know how many moles I need. In order to figure out how many moles I need of this, I'm going to need to find out how many moles I have of this to start with. In fact, I'm going to write that under there. I'm going to write, I need to know if I can find out the moles of this. I can find that out from the moles of this. That will allow me to find the grams. And I'm going to be able to find the moles of my nitric acid from this information. Molar relationships are the key. If I can find the moles of nitric acid I have, then I'll be able to find out how many moles of calcium hydroxide I need. I'm going to use a table again just to focus on moles and get you used to using the tables, even though I know some of you don't like it. It'll come in really handy when we're doing acids and bases. So we have our reaction up here. I'm going to write down what we have before, what our change will be, and what we have after. Before, And only moles go in the before change after table, which is why I like it. We can only put moles in this table. So if we look at our nitric acid, we're going to write the before moles down here. And what we're trying to find is the before moles for calcium hydroxide, because that's going to be what this is. What we write in this box here is our moles for calcium hydroxide. So how can we figure out how many moles we have of nitric acid? Well, we know that we have a volume and we have a molarity. And we know that big M equals moles over volume. Anytime you see this big M, you're probably going to use this formula. So our molarity is 0.101 big M, and that equals an unknown number of moles over 25.0 milliliters, which is 0.025 liters. I did that in my head. I converted that by multiplying the 25 milliliters by 1 liter over 1,000 milliliters. So to solve for moles now, I'm going to multiply both sides of this equation by this 0.025, and I will find out that my moles, I'm running out of room, my moles of my nitric acid that I have are going to be equal to 0.01 times 0.025, which is, I have that on my calculator, 0.002525, 0.002525. And make sure you write down all those numbers. Let's say it's 0.002 or 0.0025. You have to have at least 3 because these each have 3 significant figures. So I'm going to put that here, 0.002525. That's how many moles we have. That's this number that we were looking for right here. Okay, I'm going to use all of these moles up in my neutralization, because I want to get rid of these protons. I want them all to react and form water. If I use them all up, then they're all going to be gone. So minus 0.002525, because that's what happens in a neutralization reaction. You get rid of all the protons or whatever you're neutralizing, and that becomes 0. Now the question is, if this is the amount that's going to react of the nitric acid, then how much will react of the calcium hydroxide? Well, they're going to be in a 2-to-1 ratio. So if this many reacts of the nitric acid, 1/2 of that's going to react of the calcium hydroxide. We could figure that out if we wanted to. We could say 0.00225 moles of calcium hydroxide. And we're going to multiply, or you could use your train tracks, you're going to multiply that by a molar ratio, your moles of, this amount right here is moles of nitric acid. So I need to write HNO3 here. And my molar ratio, the way this will react with this is 2-to-1. So for every 2 moles of HNO3 I have, I will need 1 mole of calcium hydroxide. And so therefore I'm going to need 0.002525 moles of divided by 2, which is 0.002525 divided by 2. 0.001265, 0.001265. So that is the number of moles of calcium hydroxide, because that's what's here. These canceled. That will react with this many moles of nitric acid. So I'm going to write it over here. 0.00, I'll go with 1263, round up to 4 significant figures. So again, that's going to be, subtract a minus sign, you're going to use all that. So if you're going to use all of this up, you have to start with that much. 0.001263 moles of calcium hydroxide. So that's this number. I just can't fit it on this little blue line. So now we know how many moles of calcium hydroxide we need to start with. Well, if we can convert these moles to grams, we'll have our answer, because that's what it asks. How many grams do you have to start with? So let's make ourselves some more room. And I'm going to take my number of moles of calcium hydroxide that I need, 0.001263 moles of CaOH2, and multiply it by the molar mass. This is the train track method. For every 1 mole of calcium hydroxide that I have, and I need to find the molar mass of calcium hydroxide. You can pause the video and find it, or you can just have me tell you it's 74.1 grams. I'm going to multiply, and I find that that equals 0.09358 grams. I'm going to round that to 3 significant figures, 0.0936 grams of calcium hydroxide. And that is my answer. They asked for how many grams. I found how many grams I need. Woohoo! We're done with this one. So this is the end of this video. Then I'm going to pick up in the next video.